Hello and welcome back to Mathletics with Sanova. Today we are going to discuss about geometric properties of circle. And this is chapter 9 from book 4, 8th edition. And let us start it with defining a circle. Circle, as you see the shape, it is a 2D shape and we define it as of a set of points which are at equal distance from a fixed point. A set of points which are at equal distance, or we call it equidistant as well. Equal distance from a fixed point. This fixed point, which actually lies over here in the middle, is known as center, and these the set of point. It is known as the circumference of the circle, or we call it perimeter as well. And the distance between the center and the circumference, that the fixed distance, the same distance, is known as its radius. And now we start defining a few terms about the circle. The first one is arc. Arc is basically any part of the circumference of the circle. Let's say I take this part over here. So this one will be known as an arc. Its endpoint, if say its endpoints are A, B, and there is a point C over here. So I must say it is arc ACB. Okay. So arc is defined as part of the circumference. Alright. And if this arc ACB, this is known as the minor arc, while the arc opposite to it will be known as the major arc. If I take another point over here, like let's say it is D, then the arc ADC will be the major arc. The arc opposite to the minor arc is the major arc, and the minor arc is basically uh, any arc which is less than the semicircular arc. Now, coming to the chord, chord is basically a line segment that joins any 2 points on the circle. So, let's say I have a line segment over here which joins A with the D. So, this segment will be known as chord. So, chord is a line segment that joins any 2 points on the circumference of circle. And if this chord passes through the center, then we call it the diameter, and we already know that the diameter is basically double that of the radius. So this will be the diameter. The any chord which passes to the center of the circle is a diameter. Now coming to the other two definitions, which are segment and sector. So mainly a chord divides a circle into two segments. Like I have a chord AB, and if I say this one is the segment, right? The area between a chord and the arc is known as a segment, and as we can see that this one is less than the semicircle, this is less than the half of circle, so we call it minor segment, and the segment opposite to it we will call it the major segment. All right. So segment is basically the area between a chord and an arc. That is, this one is the major segment. We'll be discussing segment in the angle properties. We'll later know. Then coming to the sector. Sector is basically any area between two radii of the circle and an arc. Let's say we have these two radii, As we can see over here, there is a radial segment, and there is another radial segment, and here is an arc opposite to these. So the area occupied between these two radial segments and the arc, will call it as the sector, and there isn't any detail about the sector over here. Now there is another last definition, that is about the tangent, and tangent is basically a line segment the that passes through the circumference of the circle, that passes through only one point. Like I said, it is like this line segment that is passing through the circumference of the circle. This will be known as the tangent to circle at point C, because it passes through the point C. So these were a few definitions about the circle, the definition of circle, the radius, the arc, chord, segment, sector, and tangent. Okay. Then we move to the circle properties, which are categorized as the two. Like the first category we call the symmetric properties of circle, symmetric properties, and other category is angle properties of circle. So in symmetric properties, the properties are mainly linked with the chords and the tangents. There are two properties in chords and there are two properties in tangents. So there are four symmetric properties we are going to discuss. And there are angle properties. They mainly involve segments and arcs, or we can say the semicircle as well, because there is another property about semicircle as well. So these are the two categories of properties: symmetric properties and angle properties. First, let us today discuss the symmetric properties, and then in the next video we will be discussing the angle properties. Coming to the symmetric properties, which are four. So first we start with the property 1. Let's say we have a circle with center O, and there is a chord. Like I have a chord over here, and I name it as chord AB. This is a point A and there is a point B. And if I draw a perpendicular from the center, so the property states that any perpendicular from the center of a circle to the chord will bisect it. If I say M is the foot of perpendicular, then AM must equal BM. That is the definition, or that is the statement of first property, that any chord, any perpendicular from center of circle to a chord bisects it. Likewise here, if I have OM perpendicular to AB, then it will be AM is equal to BM, that the two sides are equal. It passes to the midpoint. Okay, and the converse of this property also holds. Like if we say that there is a line segment that is passing through the midpoint of a chord, that must also be perpendicular to the chord, right? The converse of this property also holds, right? So that was the first property, that any perpendicular from the center of a circle to chord bisects it. and vice versa. Now coming to the second property, let us we have a circle with center at O, and let us we have two chords this time. Let's say we have this one as one of the chords and there is another chord over here. Let's name it that this one is AB and this chord is CD, and then we take the perpendicular distance of the center and the chord. So let's name the foot of perpendicular M over here and N over here. So this property states that if we have two chords which are equidistant from the center, equidistant means they are at equal distance from the center, then the chords are equal in length. Like any two chords equidistant from the center are equal in length. Like we have taken two chords A, B, and C, D, and their distance from the center are OM and ON respectively. So if I say if OM is equal to ON, then AB is equal to CD. So that is the statement of this property. And once again, the converse of this property also holds that any two chords which are equal in length, they must be equidistant from the center as well. So that is why we write length, and vice versa, that its converse also holds. So that was the second property which also involved the chord. Now we move to the third property which will involve tangent. So let's say we have a circle with center at O, and let us draw a tangent to this circle at some given point. Like I say, this point is P, and there is another point at this line. Let's say it is Q. So PQ will be tangent to the circle, and this property states that the radial segment and the segment that joins the point of tangency with the center, the radial segment, and the tangent are always perpendicular. So that is the statement of third property, that tangent and a radial segment are perpendicular at the point of tangency, and the point of tangency is the point where tangent passes through the circle. So we say any tangent to the circle and a radial segment are perpendicular to each other. To each other. This property is pretty much simple. Let us discuss the next one, the fourth property, and that is some really important property. Let's say we have a circle with center at point O, and now we have two tangents which are intersecting tangents, like they intersect at one given point. Let's say I have this is one of the tangents, and there is another tangent to the circle. So let's first name the point of tangency. Like I say, this one is point P, and this one is point Q, and next the point of intersection, because they were intersecting tangents, let's name it as point T. Now this property also involves the first property, that we know the radial segment and the tangent will be perpendicular, so we must draw the segment over here as well and mention that these are perpendicular. Now we have two tangents, one is TP and other is TQ, and the first statement of this property 4 is that length of two intersecting tangents are equal. Lengths of two intersecting tangents. And what is the length of a tangent? Basically, and what is the length of tangent? Basically, it is the distance between the point of tangency and the point of intersection. That is what we call the length of a tangent, and lengths of two intersecting tangents are equal, which means that TP and TQ, they are equal in length. So I must now the second part of this property is that if we join center of the circle with the point of intersection of tangents, this this line segment bisects the shape, the quadrilateral OPTQ. Okay, so here OT bisects the shape OPTQ into congruent triangles. And the next one, which is really important, that it also bisects this angle over here, the angle POQ. Okay, so if it bisects, we know it will be POT equal to QOT. That angle POT is equal to angle QOT. That this angle equals this one. The segment that passes through the center and joins it with the point of intersection of tangents will bisect this angle, and in the similar manner, this angle over here at the point of intersection of tangent is also bisected, that it is also changed into two equal parts. And because that this angle can be named as PTO and QTO, so angle PTO equals angle QTO. So that was the fourth property, which is really important, that length of two intersecting tangents are equal. The line segment that joins center with the point of intersection of tangents bisects the quadrilateral, and it also bisects the angle at center as well as at the point of intersection of tangents. Okay, these were the four symmetric properties, and in the next video, we'll be discussing a few questions that involve the symmetric properties of circle, and next we will move to the angle properties of circle.